Okay. Operation and setup. Um, if you have interference with radios, TVs, audio systems like public address or telephone, uh, it might be due to your equipment, which can cause distorted speech in the audio of all of those devices. Uh, if you're doing single sideband, if you're doing CW, can generate a humming or clicking sound on all of those commercial or consumer devices. So, what sound is heard from an audio device experiencing RF interference from a single sideband phone transmitter?
I'm saying distorted speech.
Distorted speech. Yeah, I don't think it would make it more audible. What sound is heard from an audio device experiencing RF interference from a CW transmitter?
Well, no, I'm in the kitchen.
I'm not sure I understand why the humming. Clicking definitely makes sense.
Well, the top.
Good tone? Okay. How to eliminate interference. One of the things you can do um, is put bypass capacitors across speaker terminals for audio devices. You can apply ferrite chokes on all your audio cables. That's what's shown in the picture. You can buy them. What those are pictures showing are what they call clip-ons, where it's actually split. So it's easy to put it over an existing cable where you wouldn't be able to get the connector through the hole. So, and you can buy assortments of those off of Amazon and places where you get a box full of different sizes. You can fit them to just about any cable you have. In some cases, you can run several loops through the ferrite, which gives you more inductance and reduces the common mode on the shield. So, which of the following might be useful in reducing RF interference to audio frequency devices?
Ooh, that's good.
Bypass capacitor. Which of the following would reduce RF interference caused by common mode current on an audio cable?
Okay. Alpha.
Ferrite chokes. Preventing hum. Usually, this is what we call from ground loops, where you have multiple ground paths and different potential at different ends. So you get current flowing through these loops, which can generate hum because it's usually 60 cycle currents that are running around. So one of the main things to reduce it is to connect everything to a single point ground. Uh, and it's just a hum is just an indication that you do have a ground loop somewhere. Not necessarily easy to find, but if you are very careful and have everything tied together and to a single point ground, which goes to your single point ground out, your ground rod outside the shack, you can reduce those. What could be a symptom caused by a ground loop in your station's audio connections? Yeah, somebody says you're humming.
And I got a bird in the station.
How can the effects of ground loops be minimized?
No bonding.
Yeah, I don't like their answer, but
Yeah.
it's the best of the
Yeah.
four.
Yeah.
But bonding the stuff together is better than not doing it.
Better
But
not do,
it's better to have it bonded in a single point ground.
which is why Bruce has everything in a rack. You better not do it, do B unless it's at the entrance box. Yeah.
Okay, proper grounding. Okay, all ground conductors, you want to have them as short as possible and direct, meaning no loops or sharp bends, which increases the inductance of the wire and increases the impedance at higher frequencies. And if they're long, excessively long, they can become resonant at some frequencies. So you'll see some high voltages due to the resonant RF on them. You should ground all metal enclosures, preferably with your single point ground, but definitely some way to tie them together so they're all at the same potential, so that you don't have a voltage difference between one equipment cabinet and another one, which can give you a healthy shock or burn. And that's what we would call a hotspot, where you've got a piece of equipment sitting by itself and it's got a lot of RF on it. It's much higher potential. So you can get one of those nasty RF burns that I have not experienced yet. I don't want to.
I haven't had one in,
Yeah.
gosh. Can't believe I'm that old. I've had one in 50 years. 60 for me.
What effect can be caused by a resonant ground connection?
RF volts.
Yeah. What's the possible cause of high voltages that produce RF burns?
Ground wire has high impedance.
All right. Yeah, it'd be hard for a ground rod to be resonant.
Unless the dirt's really dry.
And insulated wire for ground doesn't make any difference. And flat braid rather than round wire, actually, flat braid is better than round wire.
Or shorts.
So why must all metal enclosures of station equipment be grounded?
Doggy.
I know. It ensures that all the chassis are at ground potential. What technique helps to minimize RF hotspots in an amateur station?
Apple.
What did you say?
Apple.
You said Apple?
No, RF hotspot. Charlie. Cluster. All right, bonding them all together.
Yeah. It doesn't matter if you build them in a metal enclosure if you don't connect them to ground.
Yeah.
Broadband electrical noise or spark gap transmission, such as spark plugs in your car. It creates noise on all bands. Power line transformers arcing over or the insulators on power lines cause that wideband noise. Arcing at an electrical connection where it's kind of a loose connection carrying power. It could be on your coax. Your connector has kind of worked itself loose, so it's not making good contact, and you're, running a few hundred watts through it. You can get arcing, and all those will generate broadband electrical noise. Which of the following could be a cause of interference covering a wide range of frequencies?
Hurricane. IR clean.
Huh?
IR king.
Okay. That was a quick one.